all about different relationships that come into play in triangles. There's some different points of concurrency. Does anyone know what a point of concurrency is? It's a point where three or more lines meet up. So we'll talk about like angle bisectors, and we'll see where they meet in a triangle. And then we'll talk about perpendicular bisectors, and we'll see where they meet in a triangle. And we'll talk about medians, which you've never even learned about before, and we'll see where they meet. And then we'll talk about altitudes, and we'll see where they meet in a triangle. So that's a lot of what we're going to do. That's not what we're going to do today. Today, we're just going to introduce something called a mid-segment in a triangle, and see how that comes into play. So starting with mid-segments, it is a segment connecting, any guesses? A mid-segment connects what? Midpoints, the middles. So you're going to connect the midpoints, I don't know what that was, of two sides of the triangle. So if you look at the triangle off to the right here, if D is a midpoint, which it shows you it is because those are marked congruent, and then if E is a midpoint, which it shows you it is because these two are marked congruent, okay, then what is the mid-segment? DE would be your mid-segment. So an example of a mid-segment here is segment DE, okay? It is the line that connects the midpoints. Can anyone guess how DE relates to AC in this picture? They're parallel. Okay, so that's one of the things that will always be true about a mid-segment is they'll be parallel to each other. That's not true. Not mid-segments are parallel. A mid-segment will always be parallel to the third side of the triangle. Okay, so that's one thing. Any guesses how the length of DE relates to the length of AC? I don't ever think it looks like this, but it's true. Half. It's what? Half. Yep. So whenever you draw a mid-segment in a triangle, it will always be half of the length of that parallel side to it. So here's what it says. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half as long. Okay. So if you look at that picture, it says using the diagram above, if DE is the mid-segment of triangle ABC, then if we put these two concepts into more symbolic form, we would be saying segment DE is parallel to segment AC. And then we would say DE as a length is half of AC. Okay, so if you take the length of AC and you cut it in half, you would get DE. Now there's another way you could think about this. Instead of cutting one in half, what could you do to the other one? Multiply it by 2. So you could say doubling DE will equal AC. Okay, so that relationship is the same. It's just a matter of which perspective you take on it. But one is always half of the other, or one is always double the other. Okay, now I just have a quick warning for you. If I tell you that this has a length of 10, some of you are going to be tempted to tell me that AC has a length of 5. Tell me why that's not reasonable.
Because AC is bigger.
AC is obviously bigger, okay? So I need you to be reasonable thinkers when you're giving me answers to these problems, because it's tempting to go the wrong direction with it, but your brain can tell you that's the wrong direction because the longer one should be the bigger number, right? So as long as you're reasonable, you'll remember, oh, that means this one's 20. Okay, so take a look. It says to identify all of the parallel segments. I'm not going to make you do all of these because I feel like it's a little bit of a silly task to have to do all of them. So who can just give me one set of parallel segments here? What would be parallel to what? Eli. Sure? Give it a go. I like mistakes, remember? Taylor, did you have your hand up?
Yeah.
Okay, you give it to me.
QR parallel to WY.
Okay, QR is parallel to WY. Is that correct? Yeah, This segment is parallel to that segment. Okay, you could have said XY and QS. You could have said XW and RS. Lots of parallels there, okay? All right, look at number 4. Number 4 says if F, G, and H are the midpoints. So this is a midpoint, this is a midpoint, this is a midpoint. That means these are congruent. That means these are congruent. And that means these are congruent. I find it super helpful to mark that if you're not going to remember it once you have other things drawn in. But you don't have to mark it. So here's what it says. I would label what you know. FG is 9. Okay, so I'm going to put a 9 right there. GH is 7, so I'm going to put a 7 right there. And CD, so I'm going to go like this, so I know I'm talking about the whole thing, is 24. Okay? Knowing what I told you, see if you can figure out what is CE, what is DE, what is FH, and then get real fancy. What's the perimeter of triangle CDE? Feel free to chat with your neighbor. See if you can work that out. Yeah, leave your phone. I have a lot of apps. Oh, I am recording. All right. Tell me what you got for CE. 14. So if you know that this length is 7, then this would have to be double that. What does that mean for CF? It would be 7, right? These are going to be 7 and 7 because these are congruent. So if the whole thing is 14, then each individual piece is going to be 7 and 7. So CE is 14. You're just doubling 7. What was DE? What is it? 18. If this is 9, then this is going to be double that. So DE is 18. What's FH? It's not 9. What is FH parallel to? CD. And CD was 24, so you're going to cut that in half. So FH is going to be 12.
How come it isn't 9?
It's always half of the one it's parallel to, and it's parallel to this 24 side. So you're cutting that in half to get 12. The 9 would relate to this one, the blue with the blue, the orange with the orange. Scarlett.
I'm confused, like, how do you know it's parallel? Just, like, 'cause there's a triangle.
Because they've told us that they're midpoints.
Oh.
So when you have midpoints, you have a mid-segment, and a mid-segment's always parallel to the other side.
Okay.
Okay, did anyone find the perimeter? What'd you get, Connor?
56.
56. Anybody else get 56? Yeah? 56 it is. So your perimeter would have been 24. This one we said was 18. This one we said was 14. So you're just going 14 plus 24 plus 18 to get the perimeter. Good there? Okay. This gets a little bit fancier because now it's not just a number that you're doubling or cutting in half. Okay. Look at number 5. Actually, sure. Let's do number 5. If this is your setup, okay, this is a mid-segment because these are marked congruent and these are marked congruent. What's the relationship between 7x and 17x minus 18? Yeah, Ruby.
Double of 7x equals 17x minus.
Right. Okay, so here's the thing. You could cut this one in half, but then you get a decimal or a fraction, however you want to think of it, okay? So oftentimes it's easier if you double the other one because you don't end up with decimals and fractions then. So what she said is double the 7x and it will equal the 17x minus 18. Can I tell you what some of you are going to be tempted to do? It happens all the time. People see an expression instead of numbers, and they just set things equal to each other, okay? it is pretty obvious if you look at the picture that this is not the same length as that, right? So don't set them equal to each other. They're not equal. You have to double the shorter one and it will equal the bigger one. So if we double that, you get 14x equals 17x minus 18. You can move the 14x whichever direction you want. I'm just going to work with negatives here because it's less work this way. So you get a negative 3x equals a negative 18, and then divide, and x will equal 6. How can you check your answer? If you plug it in, are you going to get equal things? No, you should get one that is half of the other, right? So if I plug a 6 in, 7 times 6 is 42. If I plug a 6 in here, I should get 84 if it's the right thing. Don't expect them to be equal. They won't be equal, okay? Questions on that? Okay, so we're not going to do this one, but just tell me what you would do on number 6. Double the 6x plus 31. Now, if you're going to double it, which property needs to get used? Distributive property. So if you double that, then it will equal the 19x minus 36. So just make sure you distribute if you're going to do it that way. Could you have cut 19x minus 36 in half? You can. You're just going to get a decimal, okay? Could you have doubled 19x minus 36? No, right? Then if you double this, it's way longer than that guy, right? So double the shorter one or cut in half the longer one, but just make sure you're not swapping those and doing the opposite thing, okay? We good there? Okay. Next page. Here, let's do this. You try number 7. See if you can set what you got for x. X equals 9. So you had to double the 4x plus 1. Some of you just went right to 8x plus 2. That's fine. And set that equal to 11x minus 25. And then solve for x. It came out to x equals 9. Okay? Questions on that? Fantastic. Oh.
Do we not plug it into DE or not?
Oh, you're right. This one asked for DE. What would you get for DE?
36.
So 37, 9 times 4, so 36 plus 1, so DE would be 37. Nice catch, Blake. Okay, questions? Okay, jump to number 10. Number 10 brings in chapter 4. Did you love chapter 4 as much as I love chapter 4? Love chapter 4. Actually brings in chapter 3 as well. If we're going to find the missing angles here, first of all, do you see an isosceles triangle? Do you see an equilateral? Do they mark all the sides congruent for you?
No.
Do you see isosceles?
Yeah.
Where?
Oh, wait, no.
There might be isosceles. Did they mark anything isosceles for us? No. So you have to be a little bit careful because it's tempting to be like, oh, those are congruent and those are congruent, so then these must be congruent because it's isosceles. But it's not. It would have to be this whole side is the same as this whole side, right? Not the pieces are the same as the pieces. So just be careful with that. We're not working with isosceles here. So let's just think back to some of the things we know in a picture like this. Because they marked these congruent and because they marked these congruent, we know we have what? Okay, what's that called? A midpoints, which get us a mid-segment, right? So we know we have a mid-segment. What do you know about a mid-segment and the side across from it? It's cut in half and they're parallel. Okay, so even though they didn't mark this, I know those are parallel lines. What do parallel lines get us? corresponding angles. Yes, so if this gets us corresponding angles, which angle do you know? 4 is what?
59.
Yes, 4 is 59. Those are corresponding. So angle 4 is 59 degrees. What else do we know right now?
3 is 127.
3 is not 127 because they didn't tell us if this was parallel, like if they put a line there, then that would work, right? This angle would be 127, but they didn't give us a line there.
180 minus 127 is 53.
And which angle does that represent?
Angle 2.
Okay, angle 2. So you have a linear pair right here. So if you go 180 minus 127 and get 53, that would be this angle. Angle 2 is 53. What else do you know?
180 minus 59 equals angle 5.
Okay, another linear pair right here. So you can go 180. Is that the 59 you were using, Ruby? Or were you using the other one?
What do you mean?
Were you using this 59 or this 59?
The other 59.
The first one? Okay, so linear pair. Could you use this one? What are those?
Those are their same.
Those are same side interiors, right? You have parallel lines. Those are same side interior angles. So you can use it either way. Either way, it's 180 minus 59, right? Because same side interiors are supplementary. So subtract that. What do you get? 180 minus 59. 121 degrees for angle 5.
Be next, like 59 plus 53 in the mid. Angle 3 equals 180.
Yeah, now you have a triangle, right? Here's a triangle right here. So in that triangle, 59 plus 53 plus the measure of angle 3 should equal 180. So you can take away, what is that, 112? So the measure of angle 3, 180 minus 112 would be 68 degrees. What's 1? 53. It's corresponding to this guy. Or you could say it's a same side interior with the 127. Michael. Yeah, will you leave your phone, please? Yes. Okay, so questions on that? Lots of little pieces, right? Look for same side interiors, look for correspondings, look for, alternate interiors, but those don't show up a whole lot in these triangles, but they can. So, good there? Ryan?
You could use the big triangle to find 3.
Yep, totally. You could go like this, right? And then it would be 59, whatever one came out to, 53, and angle 3 have to add up to 180. Yep, any triangle always adds up to 180. Okay, 2 more. Look at number 12. 12 says find the value of x. How are we going to do that? What? Set them equal. Why can we set them equal? They're corresponding. Because of these markings, okay, you have to have those markings. You can't just assume it's a midpoint. So because they're showing us these are midpoints, then I know the lines are parallel. And if those lines are parallel, then these are corresponding, right? So we're going to say 7x plus 4 is equal to 10x minus 11, and then solve that. So take away the 7x and add the 11, and then divide by 3. So you would get x equals 5. If they asked for the measure of the angles, then you would plug them back in, but this one's just asking for x. Okay, you do number 13. Find the value of x. All right, tell me what you did. Did you set them equal to each other? Oh, good. Don't do that. These are parallel, which makes these what kind of angles?
Same size.
Same side interiors, right? What do you do with same side interiors? You don't set them equal.
You add them and then you set them to 180.
Yes, they're supplementary. So you're going to go 5x plus 2 plus 11x minus 30 equals 180. Okay, and then solve that. So 16x minus 28 equals 180. Add your 28. So 16x equals 208. And then divide by 16. That comes out to 13. Okay. If you don't feel good about it, plug it back in and check. If I plug a 13 in here, 13 times 5 plus 2 would be 67. Does that look, oh, look at that. Does that look about like a 67-degree angle? I'd say yes. Okay. So just check, is it reasonable? Did it make sense for what we're working with? Good there? Okay. That's it. Piece of cake, right? Lines are parallel. One is half the length of the other.